Hi guys, it's the Sciencebarbie. Today we are going to calculate the determinant of a 3x3 matrix. Now we have here three different matrices, D, E, and F, and we see that all three matrices are 3x3 matrices. They all have 3 rows and 3 columns. And we're going to calculate the determinant, which is the volume that here the 3 vectors generate in a 3-dimensional room by applying something French. It's called the Rule of Sarrus. The Rule of Sarrus. Sarrus is a French guy, French mathematician, nothing to do with Sauron from Middle-earth, though my students probably sometimes think they're on the way to Mordor. No, it's Sarrus, it's a French guy, and we're going to apply his rule. How does this work? It's quite easy. Now we have the determinant here, and obviously sometimes at university you just learn formulas by heart, and then you have to panic that you might forget them. No need here. What we do is we extend the original matrix by the first 2 columns, like here 4, 10, minus 6, and here again 2, 5, and minus 3. And we do this here too. 1, 0, 5, minus 2, 3, minus 1, and here we have 1, 2, 0, and 0, 5, 1, and then we take 2 colors. One color to refer to everything that's being added up. These are the 3 main diagonals here. We highlight them here too, first in pink, and then these are being added up here too. And this is how we're going to start. Now everything that's here in purple is being added up. Let's make a plus sign here to be clear about that. Now let's start. We start here with the first diagonal. It's 4 times 5 times 1, it's a plus sign, 2 times 0 times minus 6, plus 1 times 10 times minus 3, here 2, 1 times 3 times 4, plus minus 2 times 2 times 5, plus, here we have 7 times 0, like that, because it's going to disappear, times minus 1. And also here, for the last example, it's 1 times 5 times 5, plus 0 times 4 times 0, plus minus 1 times 2 times 1. Now we take a different color. I got blue. And then we do the other 3 diagonals, this one, and this one. And now we see why we extended the matrices at the first place, because now we're going to subtract, already indicated by the color. So anything in blue is going to be a minus. Okay? Now let's do this. Here then we have minus 1 times 5 times minus 6, minus 4 times 0 times minus 3, minus 2 times 10 times 1. I'm going to calculate this. Now we're here. It's again minus 7 times 3 times 5, minus 1 times 2 times minus 1, minus 2 times 0 times 4. And now for the last matrix, for matrix F, also minus 1 times 5 times 0, minus 1 times 4 times 1, minus 0 times 2 times 5. Okay, and I think here I might need a calculator because I don't want To ruin it at the very last step, what I start with, I just cancel out anything that has a 0 as a factor, because this I can't forget. Any product including 0 is going to be 0. I don't want to bother about that. Here I have the 0. I'm not going to use this one. It's not they're not there, but if I multiply by 0, it's going to be 0. I'm just not going to bother about these any further. And here's 2. Okay, now just to make no mistakes, I'm going to use my calculator, even though it's a little bit embarrassing. I can live with that. Now here we have 4 times 5. Now here we see it's a minus. Let's use this. 3 times 10. Oh dear, no. What you're thinking, plus, because here it's minus and minus is plus. 5 times 6. And here again it's minus. 2 times 10 is 0. So the first determinant here, you can see this, is 0. Now we're going to have a look at that. Why is that 0? It's 0 because if we look, the determinant of matrix D is 0. This indicates us that either the columns or the rows are not linearly independent from each other. And if you look here at the second column and the first column, we can see that these two columns are linearly dependent from each other. Why? If we take the second column and multiply it by 2, we get the first one. 2 by 2 is 4, 5 by 2 is 10, and minus 3 by 2 is minus 6. So these two columns here are linearly dependent, and that's why we get the determinant of 0 here for matrix D, because the column vectors are not independent. Now let's go to the determinant of matrix E. We start here, 3 times 4. Now here we got a minus sign, 2 times 2 times 5. Then we move on here, minus 7 times 3 times 5. Again, here it's minus times minus is plus. Okay, that's 2. And we get minus 111. Okay, I hope you can see that it's minus 111. This means this matrix here, all the columns and all the row vectors are linearly independent from each other. We get a real value for the determinant. Doesn't really matter that it's a negative value. It doesn't disturb you any further. Now let's go to the last one, matrix F. It's 5 times 5. What's the next one? It's a minus. Here it's 2. Then again it's a minus. Here it's 4. Okay, I could have done this in my head. It's 19. Again, it's just a positive value, and that's also fine for us, because then we know the row vectors and also the column vectors of matrix F are linearly independent. And for example, what we could do next is calculate the inverse of matrix E and inverse of matrix F, because they have determinants that are not 0, while we cannot do the inverse of matrix D, as the column vectors are linearly dependent from each other.
Das war ein Mathematik-Tutorial der Sciencebarbie. Jedes Like und Abo des Kanals freut uns sehr. Für Feedback und Kommentar nutzen Sie die Kommentarfunktion.